This is an instructional video about classifying rational numbers. And so the essential question is, how do I classify rational and irrational numbers? So there are a couple different types of numbers that students have to know. And the most basic ones that we've learned up to this point through our education is natural numbers. They're called the counting numbers, so it includes 1, 2, 3. So basically, if you have it on your hands, you can use your body to count it. It's called a natural number. Then there's whole numbers, which are 0 and all of the positive numbers. And then you have integers, which is kind of the introduction that we had beginning of 7th grade. And integers are the counting numbers, and then their opposites, and also 0. So you can see up here that there's the relationship. You have your natural numbers, and then your whole numbers, and integers are everything over here. Now, the piece that we're really focusing on now is, what are rational numbers? And rational numbers are essentially any number that can be written in fraction form. So those are integers, fractions, terminating decimals, meaning that they stop, repeating decimals, so if it's 0.3 repeating, or square roots of perfect squares. So here come examples here. So we got 6 1/5. This is considered rational, but it's not natural, whole, or an integer. The square root of 16 is actually 4, so that's a natural number, it's a whole number, it's an integer, it's rational. 0.35 and 7.5, these are examples of terminating decimals because they stop. So these two will be considered rational numbers. And then these guys here, these are repeating decimals. And actually, this one's the fraction 1/3 and this is the fraction 8/11. So you can see that that's how we classify the numbers. We kind of ask ourselves those questions. But then here's the other piece. Well, what about things like this? The square root of 2. Now I know that I know that 1 times 2 is 2, and 1 plus 1 gets me 2. So a lot of students tend to think like, well, it's a perfect square. But it's not, because can't think of two numbers that are the same that multiply to get me that. Plus, if I go with my calculator, the square root of 2 is like 1.414136, and it goes on and on and on, but it never stops. And then like the square root of 10 is 3.16, blah, 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 blah. So bottom line, an irrational number is anything that doesn't stop and doesn't repeat, and it's a square root of a non-perfect square. Not just and, but or. It's any square root that's not perfect root. So you think about so our perfect squares, are 1, 4, 9, 16, 25, 36, 49, because I know that if I take the square root of those, I can get a whole number, because 4 times 4 gets you 16. 2 times 2 gets you 4. And I always think about visually like making a square, because I know that the area of a square is one number times itself. So basically any number that's not those, that would be considered an irrational number. So the other piece that students have to know is, let me jump down to here. What about when I have things like this? So I can take a number by itself and figure out what it is, but then I also have to know, what about if I have 3 plus the square root of 7? Is this going to be rational or is this irrational? And you know that 3 is a rational number, but the square root of 7 is irrational. So if I take a rational and combine it with an irrational number, what's it going to turn out to be? Well, actually turns out that's going to be irrational, because if you think you have 3 plus the square root of 7, you type that in your calculator, you're going to get a decimal that won't repeat and it won't stop. It'll stop on your calculator because it only has so much spaces for digits in its view, but you won't see a repeating pattern. And you know that the square root of 7 is irrational. So these are the different things that we can remember. So if I'm adding two irrational numbers, that's irrational. Multiplying two irrationals, that's irrational. Basically, the only time that my answer is rational is if I'm adding two rational numbers, subtracting, multiplying, or dividing. So both, you can see here that both numbers have to be rational in order for your answer to be considered rational. So there you go. That's how you classify